All right, question number 3. This is just going over the definition, and it wants us to state the definition of the precise definition for limit. They've used different values, but it's the same. So we're saying the limit of g of z as z approaches d is equal to m. And so what does that mean? So that means for any number epsilon greater than 0, there is a corresponding number delta greater than 0, such that 0 is less than the absolute value of z minus d, so that'll be your 2x coordinates, which is less than epsilon. So this is going to be incorrect because if you think about it alphabetically, x comes before y and d delta comes before e epsilon. So I always note that the delta goes with the x coordinate, so this will be incorrect. Any number epsilon, there's a corresponding delta such that g of z minus m, it says greater than epsilon, this should be less than. So c is out. Any epsilon, there's a corresponding delta such that g of z minus m is less than epsilon, so that gives you the right form, but it is missing the absolute value. Okay, so far A, B, C are wrong. Let's look at D. Any number epsilon greater than 0, there's a corresponding delta such that the absolute value of g of z minus m is less than epsilon. So these are your two y coordinates. This is your f of x usually, and this would be your L. So those matches whenever 0 is less than z minus d, so your two x values, and that's going to be less than delta. So this is the one that matches the precise definition with the new variables. So we'll choose D. All right. And then question number 4, we have two parts. So it says we have this function. It says the limit as x goes to 2 of f of x is equal to 4. And we're going to determine the largest value of delta. So we're looking for the x-axis that's greater than 0 that satisfies each statement. So if we look at A, we're trying to find a strip around x so that delta, x minus 2 is less than delta. And then we're given f of x minus 4 is less than 2. So the limit is 4. So if we look at 4, we're told that the strip around y is going to be within 2. So if you think about absolute value, the strip around that being less than 2 is giving us the same idea here. One way you can think of it is just adding and subtracting that to both sides. So remember solving absolute value equations. If I have f of x minus 4 is less than 2. Okay, if you recall from absolute value, that means whatever is here could have been positive 2 or it could have been negative, and it's going to be less than 2. So we can set up two expressions. We can say that f x minus 4, and then we can say when you flip the sign, because it has to be negative, or we can say f x minus 4 less than 2. And so basically when you're doing this, we would add 4, and so that would give us f of x has to be greater than, if you add 4, it has to be greater than 2, and then if I add 4 to both sides, I have f of x has to be less than 6. So you get a number line that goes from 2 to 6 in the y direction. It would be the same as if you were to take this 4, which is the midpoint, and add 2 and subtract 2 from it. But you get 2 to 6, okay? So that's going to keep you within 2, less than 2. So you start at 4, you go up to 6, and look at where that intersects the graph. Okay, so start at 4, go up to 6, that intersects the graph here. We're going to drop that straight down and see where that intersects the x-axis. Intersects at 1. So on one end, we are looking for interval 1 up 2. Now if I go to 4 and I drop down to 2, So that's the other part. And we're going to go straight across and see where that intersects our graph. That intersects here. We're going to drop straight down and we get 3. Okay. So our x should be in the interval 1 to 3. So we were already given that x minus 2. So 2 is kind of like that midpoint. So if you think about either side of 2 going to the extremes, 2 to 3 is a width of 1 and 2 to 1 is a width of 1 on either side. So that lets me know that if I'm doing x minus 2 in this range, that delta has to be less than 1. Okay, that's my symmetric interval. And then similarly, we can do the same thing for part B. So instead of going through all the rigmarole, we can just kind of look again. 4 is the midpoint, but this time we're saying the limit is 1. So I want to stay within 1 of 4. So if we go to 4 and I go up 1 unit, that's going to be at 5. 5 intersects the graph here, and we're going to drop that straight down and see where it intersects the y-axis. So within 1, which is 5, drop it straight down, we get 1.5. Okay. So I'll kind of go to the side. We got 1.5. And then if I go on the lower end, so 4 subtract 1, so I'm staying within 1, we get to 3. See where that intersects the graph, and we're going to drop it straight down. We're going to get 2.5. Okay, and the same thing, 2 is that middle number. We're doing x minus 2. So if I look at the distance from 2 to 2.5, I just get 0.5. And on the other end, if I go 2 to 1.5, I still get 0.5. So the maximum distance within this range I can go from 2 is within 0.5. Okay, so our delta in this example is 0.5.